A university task force of 8 people is to be formed from 16 members of the student government and 10 professors. Each person is equally likely to be chosen. So if they're going to randomly choose people, what is the probability that there is an equal number of students and professors? So it'll be then 4 and 4. So 4 professors and 4 students. Well, the way we can do this is, first of all, we'll figure out the number of ways that you can pick 4 students. Now, since it's part of a committee, there is not any special roles, so this has to be a combination because they're not being assigned particular tasks, it's just part of a committee, so this has to be a combination. So if we've got 16 students to choose from, and we're going to pick 4, this is the combination of 16 choose 4, which is equal to 16 factorial over 16 minus 4 factorial times 4 factorial, and that's equal to 1,820. Now the number of ways that we can pick 4 professors out of the 10 is equal to the combination of 10 choose 4, which is 10 factorial over 10 minus 4 factorial times 4 factorial, which is equal to 210. Now, the total number of ways that you can pick this committee, this is the sample set, is we've got 26 people to choose from, and you're going to pick 8. So this is with no restrictions at all. This is the number of ways that we can pick a committee of 8 out of the 26 individuals. And this will be 26 factorial over, and it'll be 26 minus 18 factorial times 8 factorial. Sorry, 20. Getting ahead of myself. That's 26 minus 8 factorial, which is 18 factorial, times 8 factorial. Now, that comes out to be 1,562,275 ways that we can pick a committee of 8 people out of 26. So the probability that you get 4 profs and 4 students, then now if we go up here, there are 1,820 ways that we can pick 4 students. And for every one of these ways, there are 210 ways that we can pick the 4 professors. So as a result, the number of ways that we can do this, the total number of ways will be 1,820, which is the number of ways we can pick 4 students out of the 16, times 210. All over our sample set, which is from up here, 1,562,275. And this works out to be approximately equal to 24.46%. Now the next question, what is the probability that at least 6 members are students? So the probability that 6 or more is equal to the combination of 16 choose 6. Now, this will be the number of ways that we could pick 6 students out of the 16 times, and if we've chosen 6 students, that means that we've got 2 professors to fill out our committee, and that'll be times 10, choose 2, which is the number of ways that we can pick 2 professors out of the 10. But now we have to add 16, choose 7, which would represent the number of ways that we can pick 7 students out of 16 times, and we've got 1 professor in this case, so it'll be the combination of 10 choose 1 plus this is the number of ways, the combination of 16 choose 8 times 10 choose 0. And so, just recapping, this would give us the number of ways that we could pick 6 students and 2 professors, plus the number of ways that we could pick 7 students and 1 professor, plus the number of ways that we could pick 8 students and no professors. And this will be all divided by our sample set, which is 26, choose 8. And that comes out to be approximately 31.2%. So question C, which outcome is more likely? Well, you're more likely to pick 6 or more students to be on the committee than you are to pick an even number of 4 and 4, because the answer before was about just over 24%.